In this lesson, we're going to be looking at the absolute value equations. So absolute value, when we think about that, those are things with the little bars outside it. They are not parentheses, but they are just like straight bars. Absolute value is the distance that a number is from zero. So it's a distance between the number and zero. It means like if you're looking on a number line, all right, so let's say we have -7. This is a distance of 7 units from 0. So a distance is always a positive value. That's why the absolute value always comes out positive. But when we look at something like this, we have the absolute value of x equals 2. So this is just saying that some number has a distance of, in this case, 2 units away from 0. And it doesn't tell us what number that is, but we can think about what number would have a distance of 2 units away from 0, so therefore x would have to equal 2. But in fact, it's not the only one. X would also mean it could be -2. So when we look at that, an absolute value really has two potential answers, because it could have been that this was a +2 or a -2, because it's still 2 units away from 0. So let's think about, what if the absolute value of x was equal to 5? Okay, well then x would be 5 or -5. What if the absolute value of x was equal to 0? So in that case, you're thinking of what number has a distance of 0 units away from 0. And the only possible option is x would be 0, because we don't have a positive or -0, it's just 0. So what if the absolute value of x equals -3? In this case, this is actually impossible. Okay, the absolute value cannot equal a negative. Okay, so in this case, a value will always have a positive distance from 0, so it's never going to have an output that comes out as negative. So in this second part, it says, explain why this definition means that the absolute value function does not have an inverse. So if we looked at that function f of x equals absolute value of x, we can do our input-output stuff. And so let's say we have all of our x values and we're mapping them to our y values. If I input a 2, we see we're going to get out a 2, because the absolute value of 2 is 2. But if I input a -2, we also get out a 2. So this poses an issue for inverses. So this is an issue for inverses because because it means that the function is not one-to-one. It means the function so it's not one-to-one, and so what that would mean is that it would fail the horizontal line test. So, and fails the horizontal line test. So we talked about what it means to be an inverse or have an inverse and to pass the horizontal line test in a previous lesson. Graphically, what we would see is when we input 2, we got out a 2. When we input a -2, we got out a +2 again. And so our graph of an absolute value function we saw looked like a V, and therefore automatically we can see it's going to fail a horizontal line test. Okay, now let's look at how do we actually solve these equations. So when we have something like this, we've got an equation to solve, the first thing we need to do is get the bars by itself. So we're going to isolate the absolute value expression. So we want to get these absolute value bars by themselves by getting rid of the stuff outside of it, like plus 4. So we would subtract 4 from both sides, which leaves us with 2/3 x plus 3 equals 6. And now that we have this expression, we're looking similarly here. This value inside could have been equal to a positive or a negative 2. In this case, this means this value inside could be equal to a positive 6 or a negative 6. So we're going to set up two equations where it says something like 2/3 x plus 3 equals, one's going to be a positive 6 or a negative 6. So the inside doesn't change. The outside, what it's equal to, did turn to a negative, but I did not change this inside of the absolute value. So if we work this equation out separately, we're just going to do one equation and then the other equation. I'm going to subtract 3 from both sides, so that would be 2/3 x equals 3 when we subtract. And then we want to get rid of this 2/3. And so one of the ways that we can get rid of it is actually by multiplying by the reciprocal and so I'm just going to write that down underneath of it. So in this case, what it does, when you multiply by the reciprocal, the 2's divide out, the 3's also divide out, because that's going to just leave us with 1x. And that's our goal. We want just 1x here. And it's actually easier to just write it that way, multiply by the reciprocal, than dividing by 2/3, because that is what division does. So if we multiply with these fractions, I get 3 times 3, that's 9, so 9/2. You could use your calculator, but you want to keep these exact values, so it's actually nicer to work with these fractions. And then we solve the same one here. So let's subtract 3 again. I get -9 this time. And I'm still going to use this trick where we multiply by the reciprocal. And that's -9/1. So that allowed us to divide. 2 divided by 2 is 1. 3 divided by 3 is 1. So I have 1x here. And then if I multiply straight across, I get -27/2. The thing with absolute value is that we do want to check our solutions because we might end up with something called extraneous solutions. So let's just check. And we can use our calculator to do that, but we want to plug it back into the very original equation. So it would say 2/3 of x, which is now 9/2, plus 3, plus 4, and hopefully that equals 10. And we're just going to use our calculator to test that out. Okay, so we have absolute value. You can get that by going to math and over to number. So there's our absolute value, 2/3. You can use your fraction bar, times, you can use your fraction bar again, 9/2, and then plus 3. You do have to arrow out of the absolute value to get that plus 4, but we see it does equal 10. So this works. You would check the other one, so I'm going to let you go ahead and try that. -27/2 is our x value, plus 3, plus 4. Hopefully that equals 10 for us. So you try it in your calculator, you will see it does work. All right, let's try number 2. One of the mistakes that I see students make is they try to distribute into an absolute value. That does not work. You can never distribute inside of absolute value. So we are going to isolate this still, but we isolate it by getting rid of the things outside. Now it is multiplication here, but we would add 4 first. So I'd say 3 times the absolute value 1/2 x minus 5 equals, and if we add 4, we actually get 0, and that's okay. Then we would divide by 3. So I want to undo that division or multiplication by using division. But 0 divided by 3 is just 0. We have isolated the absolute value, so we can set up our two equations. So I'd say 1/2 x minus 5 equals 0, and 1/2 x minus 5 equals 0. So it ends up being the same thing because a positive 0 is just 0, a negative 0 is just 0. So you can kind of ignore this one since it's the same and solve the other one. So if I add 5 to this side, I get 1/2 x equals 5, and we can use that multiplication property of the reciprocal So we get 2 divided by 2 is just 1, 1 divided by 1 is 1, so I get 1x equals 10. And then we just check it again, so let's just check. Use your calculator. 3 absolute value 1/2 x minus 5 minus 4. Hopefully that does come out to be a negative 4. So just use your calculator real quick and plug that in. All right, so we got 1/2 times 10 minus 5 outside the absolute value minus 4 comes out to be a negative 4. So we're good. You will see some later on in the future units that do have extraneous solutions. Okay, so on the back we've got a new example of a quadratic, and these are a little bit harder. You got to be more careful with them. But so we're going to set them up the same way. We try to isolate the absolute value. It's already by itself. So we're going to set up our two equations. X squared plus 2x minus 16 equals 8. Or x squared plus 2x minus 16 is negative 8, equal to negative 8. So just kind of pay attention. And so look. All right, we have a quadratic. So notice we have quadratics. I'm writing this just because we haven't done a ton of quadratic equation stuff, but we will do it a lot in this course. So quadratic equations. Hopefully this will kind of draw your attention as you're working on stuff, because to solve a quadratic equation, we actually need it equal to 0. We're not gonna like try to add 16. So I'm gonna just add a note over here for you. All right, so when solving quadratic equations, we want to get everything on one side. Get everything on one side. So that is going to make it equal to 0. So it equals 0. And we're going to try to factor. All right. So solving quadratics is a prerequisite for this course, but factoring is definitely a skill that we're going to use a ton. So you want to work on that. If factoring is new to you, you want to go look at the video and prerequisite material for factoring. But so what we're going to do is try to get this equal to 0 by subtracting 8, which would make this negative 16 minus 8, so negative 24. And then we're going to factor it. And so when we're factoring, we're looking at factors of x squared, which would be something like x times x. That's how we would get x squared. And then we jump to the constant term, negative 24, and we find out what are those factors of 24. Well, that could be 2 and 12, it could be 8 and 3, or it could be 6 and 4. And we want some that will be 2 units apart to give us a 2. So 6 and 4 would work to give me a positive 2 if this was a positive 6 and a negative 4. And you can double check that by just multiplying your two binomials to see if it gives you your trinomial. This one does factor. And once we have it factored, we can set each factor equal to 0 and solve. So I say x plus 6 equals 0, x minus 4 equals 0, and solve it out. X equals negative 6, and x equals positive 4. Now that was just one of the equations. We're going to do the other one as well. So x squared plus 2x, we add 8, but that still gives me a negative 8 here. So negative 16 plus 8 is negative 8. And we try to factor. I get x times x to give me x squared, and factors of 8 are 1 and 8 or 2 and 4. Well, 2 and 4 will work if this is a negative 2 and a positive 4. And I can set each factor equal to 0 and solve it out. So what we see is there are actually 4 solutions for this equation. Now we do need to check them, but you would plug those into your calculator and just check them to see, does this work when you plug it back into the very original equation. Turns out they all work. So we do have these 4 solutions. But we want to think about, well, what if it doesn't factor? All right, so if the quadratic doesn't factor, we have to use the quadratic formula. And so we'll see that in a later example. All right, example 4 here, we've got something kind of similar to what we have been using. So I'm going to isolate this absolute value by getting rid of the 3 first, which means negative 5, absolute value 2/3 x plus 4. And if I subtract 3, I get a negative 2. We want to get rid of this negative 5, and the mistake I see students make is trying to add 5 over, but this isn't minus 5. This is a negative 5 times the absolute value. So to undo multiplication, you want to divide. So we would divide both sides, which gets rid of the negative 5, but makes this negative 2 divided by negative 5. That's a positive 2/5. It's okay for it to be a fraction as long as it's equal to a positive. So what we've got here are 2 equations that we're going to set up. 2/3 x plus 4 equals a positive 2/5, or 2/3 x plus 4 equals a negative 2/5. We're going to solve this the same way. Subtract 4, and you can use your calculator for this to subtract your fractions. 2/5 minus 4. And you want to keep it in fraction mode right now. So negative 18/5. And then we're going to use that trick where we multiply by the reciprocal to get rid of the fraction here. So what that did was 2 divided by 2 canceled out, 3 divided by 3 canceled out, so I have just x. And we can multiply this in our calculator, but I'm going to show you just kind of that trick with multiplication if you remember them. We can reduce this fraction diagonally. So 18 divided by 2 does reduce because 2 can go into both factors. So I'm going to divide this and say 2 divided by 2 is just 1, and 18 divided by 2 would be 9, so that's a negative 9 when we reduce. You multiply straight across, so you get negative 27/5. And then we solve this other equation as well. So 2/3 x, and we subtract negative 4, or subtract 4, so I get negative 22/5. And then we do our same multiplying by the reciprocal trick. 2 divided by 2 canceled out, 3 divided by 3 canceled out. So I just have x on the left, and then we can divide again to reduce. I'm going to do 2 divided by 2 is 1, 22 divided by 2 would be negative 11 here. So I get negative 33 fifths. Again, you could use your calculator for that whole process if you wanted to. Just kind of keep them in fractions. All right. Example 5, if you want to stop and try to do that one on your own, you can. Just double check your work. But for this one, we've got something already isolated. So let's separate them out into our two equations. It's a x squared minus 2x equals 8, or x squared minus 2x equals negative 8. So we would subtract 8 over here, which gives me x squared minus 2x minus 8 equals 0. We've got it equal to 0. That's good. We can try to factor it. X squared is x times x. Factors of 8 would be 2 and 4, or 1 and 8. So 2 and 4 do work to give me a negative 2 if this is a positive 2 and a negative 4. And then we set each factor equal to 0. So x plus 2 equals 0, and x minus 4 equals 0. Solve it out, x equals negative 2, and x equals positive 4. So we've got our factoring done. Let's look at the other one when we add 8 to both sides. This turns into something that's not factorable. So we just kind of think about why. X times x would still give me x squared, but your factors of 8 would be something like 2 and 4, but we need a positive 8 this time, which means they're going to have the same sign. So if I had positive 4 and positive 4, that gives me a 6x, not 2. If I have a negative and a negative, that's still negative 6x, so this does not factor. And you could try 8 and 1, but it's still not going to work. So this is not factorable. So we use the quadratic formula. All right, if your quadratic formula is something you don't remember, that's okay. We're not going to use it too much in this first unit, but we will use it a lot in the later units. So the quadratic formula would be negative b plus or minus the square root of b squared minus 4ac. And that is all over 2a. So that's our quadratic formula. The a, b, and c values come from our coefficients in the quadratic equation. So a x squared is 1 x squared. Negative 2 makes that b value, and 8 is our c value. So we just plug that back in here. Negative b would be negative 2 plus or minus the square root. B squared would be negative 2 squared minus 4. A is 1, c is 8. And it's all over 2 times 1. So we kind of work that out a little bit at a time. We don't want to plug that all into our calculator at one time. But negative makes that positive 2 plus or minus the square root of, then we just work that part out. So you could do negative 2 squared in your calculator. But if you are going to do negative 2 squared in your calculator, you have to put it in parentheses. So what you'll notice is when it's in parentheses, it gives you a positive 4, and that's what it should be. A negative 2 squared without parentheses will tell you a negative 4, because it's squaring before it makes a negative. But what we really mean is negative 2 times another negative 2. And negative times a negative always comes out positive. So if you have plugged that in there, you get a negative 28 underneath the radical. And if you try to put that in your calculator, negative square root negative 28, you're going to see it has a domain error. And we've talked about how you cannot square root a negative. So for now, we know that this is a non-real answer. And we'll talk in the next unit about this being an imaginary number and kind of working through that. But for now, we've just got 2 solutions to this equation. Okay. If you are going to graph this on Desmos, that's another way to check your solutions. You're going to need to type this in by using absolute value of something. So you just type in ABS parentheses. So if you're going to type this in like this, you would input it this way into Desmos. But I do want to address these special important cases. So if you have the absolute value of 2x plus 9 equals negative 5. The thing that we've talked about is that the absolute value here will always come out positive. So this left side always comes out positive. In that case, therefore, it will never equal negative 5. If it's never going to equal negative 5, that means that the solution is actually no solution. All right, if we looked at this example here, we still want to get the absolute value part by itself. But one of the errors I see students make is trying to add these two together to get 14, but that's not how order of operations work. All right, think about if you were solving out this equation that said 12 plus 2a equals 8, you would not add those together because this is being multiplied to this a value. So you would subtract 12 first. That's exactly what's happening here. We're not going to add those together. We need to subtract 12 to both sides. So that gives us 2 times 5 minus x. And then 8 minus 12 is negative 4. Now we can divide by 2. So I have absolute value 5 minus x equals negative 2. But before we even try to go on, we need to look at what's going on in this equation. So again, we get to this situation where this absolute value always comes out positive. All right, so therefore, it will never equal negative 2. Thus, we have no solution. Okay, so those are our notes, but I do want to at least look at 2 of the lab manual questions, just to kind of clarify some errors that I see. So in the lab manual, you're going to see on page 51, but look for the topic of just absolute value equations. In number 7, students try to solve this one and they get confused, but this is just dividing by 4. So before, to isolate your absolute value, you need to multiply both sides by 4. So that it's going to be absolute value 2 minus 3w equals 8. Then you can work that out. The other thing is number 6. This often, kind of like the last example, students try to combine those to give me negative 11, but that's not okay. All right, same situation. If you have negative 8 minus 3a, you cannot combine those to get negative 11a. All right, you have to add 8 to both sides first. So that's what we would do. Add 8. Let me erase this part so that no one thinks that you can do that. Add 8 to give me negative 3 times x minus 1. And then if you add 8, that gives you a negative 24 here. We would divide by negative 3 to have absolute value x minus 1. And this luckily comes out positive 8. Okay, if it was a negative, we're automatically going to be stuck in that no solution issue. And so you can kind of continue working that out from there, but that hopefully will address all the possible issues that you'll run into.